Geometry Chapter 8, and I want to spend a little bit of time talking about an exact answer versus an estimated answer. Now, we talked about this in class. I'm not going to spend a lot of time on it. I'm just doing this so you can kind of have something to reference when you begin your trigonometric homework. As we talked about, the trigonometric ratios, the vast majority of them are irrational numbers. They're numbers whose decimal doesn't repeat and whose decimal doesn't end, and so your calculator can't possibly give you an infinite number of digits, and you can't possibly write down an infinite number of digits, so we always stop writing at some point, and as soon as we stop writing, we have now rounded off that number. So we don't want to do that in the math class. In the math class, we want to give an exact answer the majority of the time. When you're in science class, because you're measuring things, you have to estimate because it's impossible to measure anything exactly. Every instrument, no matter how precise it is, has some margin of error, and so nothing is really measured exact, so those are all estimated answers. And in science, you're dealing in most cases measuring things, lengths of things, size of things, weight of things, whatever. And so you work with estimated answers, and so your science teacher will probably tell you that estimate answers are okay. And I'm okay with that too. But in math class, I want exact answers, because in math class we're doing the algebra behind the estimated answers, and so we want to stick with exact answers as much as possible. A couple of general rules of thumbs in order, if you're confused about when should I use the calculator, when should I not use it, kind of keep these couple things in mind. Number one, if you're working on a word problem, then you're probably finding the measure of something. Most word problems are describing something, and now we're applying the mathematics that we learned to a problem to try to measure something. So in that case, an estimated answer would be okay, and using a calculator at that time would be alright. The second rule of thumb is to try to only use your calculator once. The calculator should really only be used once, if at all, at the end of the problem, when you're finally calculating your final answer. Any calculation that you do between beginning the problem and ending the problem, as far as finding out what a number is and then taking that number to calculate something else, is in most cases not necessary and a waste of time. Those intermediate calculations don't mean anything to the final answer. We're only concerned about the final answer. And with today's technology, we can do all the algebraic manipulation by hand, and then when we get to the end, just enter in that last expression, and the calculator will calculate it for us. So generally speaking, we're not going to be using our calculators a lot, or we shouldn't be using them till the very end, and unless we're working on a word problem, we might not use them at all. Okay, now those are general rules, so that means that there will be times where we will break those rules, but generally speaking, that's how we want to think about when we should use our calculator. So as I said, in general, the calculator should not be used until the final step. So what steps should I see then as far as your work? So when we are required to give an estimated answer because the problem says round off to the nearest tenth, or because we're finding the length of some thing, then this is what I must have on each of your problems. I must have the exact answer. In other words, I should have the starting point of your problem, all the algebra work should be done, and then down at the end, the very last thing I should have is just what the variable or unknown measurement equals in an exact form. Something like simplest radical form is exact, so I'd rather have 2 square root of 2 rather than calculating 2 times square root of 2 and getting some decimal answer. So I should have all of that work on the paper so that I can see what your exact answer is. And this is very important because on some tests I will tell you you can't use a calculator, all answers must be exact, and so you're going to want to practice this so that when you have to do that, you're prepared. The second thing to do, if we do have to round off, the way I want to round off is I want you to write down all the digits that you need in order to round off and no more. In other words, if I ask you to round off to the tenths place, the only place that you need written is the tenths place and then one past that. So hundredths place is all the are all the digits you need to write. If you write down digits past the hundredths place, which you're not going to be using to round anyways, then that's too many digits. I don't want that on your paper. So just the digits that you need, that you're going to use to round to whatever place that you're rounding to. The third thing is make sure that you're using the approximately equal sign. That's this little squiggly line here. That should be over here. I don't know how that got over there. But we're using the approximately equal to sign when we go from our exact answer to the estimated answer. Again, I want you to know, I want you to communicate to me that you know the difference between what an exact answer looks like and what an estimated answer looks like. I want you to communicate to me that you know the difference between what an exact answer is and what an estimated answer is. And the only way for me to know that is if you use an equal sign when you mean equals and approximately equal to when you mean about equal to. And so you need to communicate that clearly. And then finally, make sure that you put a digit place or a digit in the place that you're rounding to, even if that digit's not going to change the value. And we talked about this in class, the difference between 27 and 27.0. 27.0 communicates an accuracy to the measurement that's different than 27, even though the value is the same. Okay, so those are the steps, those are the things that need to have, or you need to have. So let me do one example for you so you have that example, and then when we in the next video do some examples using the tangent ratio, you'll see me talk about this over and over. But I'll just do one more in this video to round things up. Get it? Round things up. I'm going to wrap things up. Okay, anyways. So my instructions are to use the tangent ratio to find the missing length and then round that answer to the nearest tenth. So because it tells me to use the tangent ratio, I want to think about using the tangent ratio, solve it using the algebra, giving the exact answer, and then use my rounding procedures. So I remember that the tangent ratio is equal to the opposite side over the adjacent, so I find the angle that I'm given. I look to the opposite, that's W. I look to the adjacent, that's 10, and so I write my ratio. The tangent of my angle is equal to the opposite over the adjacent. I then use my algebra to solve for W. So W is solved for, so I know what the length of W is. It's exactly 10 times the tangent of 54. This would be my exact answer, so this is where I would have to see this. So I need to see your work, where you started from, and then the arithmetic that you got to arrive here. Now that I've written my ratio and done the algebra, now I use my rounding procedure to answer the question. So to round off, I put 10 tangent 24 or 54 in my calculator, and I'm rounding to tenths place, which is right here where the 7 is. The only digit I need in order to round to the tenths place is the one that's next to it, hundredths place, so that's the only digit I write. I don't write all those other numbers past hundredths place. And again, if you don't stop here, I'm going to assume that you don't know where tenths place is and you don't know how to round, so I'm going to have to mark you wrong. Not just to mark you wrong, but so that you'll recognize you don't, you have something here that you're not sure how to do, to make sure you correct it and learn how to do it. That's what a grade is for, really. When I mark something wrong, it's not so I can deduct points from you. It's so that you can see what you did wrong and then correct it, so you don't do it wrong the next time. So tenths place here is 7. The sixth I need in order to know I'm going to round this up, and so I round up to about 13.8. And then again, you'll notice that I went from exact answer equal to estimated answer approximately equal to. So make sure you have all these components when you're doing an estimated answer. If I just want exact answer, you would stop right here, but I will still need to see your work and then use the procedures that were given to make sure that we have everything taken care of.